Welcome to Chemistry Simplified. Our topic for today is acids and bases. In chemistry, there are three definitions of acids and bases, but we'll only talk about two of them in this presentation. The first definition we'll talk about is by Arrhenius, and according to Arrhenius, acids are defined as substances that produce hydrogen ions or H plus in solutions. For example, if you take HCl gas, which is hydrogen chloride, if you were to place that in water through a process referred to as ionization, it would separate into H plus, which is hydrogen ion, plus Cl minus, which is referred to as chloride ion. Now let us talk about Arrhenius' definition for bases. According to Arrhenius, bases are ionic compounds that produce hydroxide ions or OH minus in water. For example, if we have sodium hydroxide, if it was placed in water, it would undergo ionization and produce sodium ion plus hydroxide ion. Now, this definition is very important. It says ionic compounds because in chemistry, especially in organic chemistry, there are some compounds which are referred to as alcohol. They have OH, but they do not dissociate to produce hydroxide ion in solution. So therefore, they would not fit Arrhenius' definitions of bases. Now that we are done with Arrhenius' definition, which was very simple, let's look at another definition. This time by two different chemists, Bronsted and Lowry, which were working independently, who came up with their theory. So according to Bronsted-Lowry, an acid is a proton donor, a hydrogen donor, whereas a base would be a proton acceptor. So this definition for acid base is a lot wider, a lot broader than what Arrhenius had said. So let's look at an example. So let's say we have HCl, which is hydrogen chloride. If that was to react with water, HCl is an acid, but for different reason than we had seen from Arrhenius. Why we said HCl is an acid? Because it can donate that proton. So the hydrogen would move from the HCl and be added to the water. Since water is accepting the hydrogen, it is referred to as a base according to this definition. So it's the H plus or proton acceptor. So given this reaction, we would get H3O, hydronium ion, and chloride ion. Right. So according to Bronsted-Lowry, an acid is a proton donor, just like this example shows us here. Now let's look at a different example. Let's look at NH3, which is ammonia. Let's say we take ammonia, we were to put it in water, it would react with the water, and this time here, the water is the acid. Why? Because it has a proton that it can donate. Right? So the H, one of the H from the water, move to the ammonia. So water is the proton donor, is the acid in this situation here, whereas ammonia is the base. Why? Because it accepts the hydrogen or the proton, the hydrogen ion or the proton. And this time we'll get NH4, which is ammonium ion, plus hydroxide ion. Now, if you remember the previous example, water was acting as the base, and this time water is acting as an acid. So water can either be an acid or a base depending on what it is reacting with. Let's look at one final example of acids and bases according to Bronsted-Lowry's definition. So once again, let's talk about ammonia, which is NH3. If we were to react that with HCl, hydrogen chloride, right? HCl would act as an acid. Why? Because it can donate its proton or hydrogen ion to ammonia. So we see this proton is being transferred from HCl to NH3. So HCl is the proton donor, whereas NH3 is the base. Why? Because it accepts the proton. So proton acceptors. And as a result, we get NH4 ammonium ion plus chloride ion. So let's compare and contrast Arrhenius definition versus Bronsted-Lowry. So all Arrhenius acids are also Bronsted-Lowry acids, as we have seen. All Arrhenius bases are also Bronsted-Lowry bases. However, all Bronsted-Lowry bases are not Arrhenius bases. Why? Because Bronsted-Lowry, the definition is a lot broader, a lot wider. Because ammonia, we just saw, can fit into Bronsted-Lowry's definition of a base, but it does not fit Arrhenius' definition. Ammonia does not produce hydroxide ion in solution. Let's finish our presentation by talking about some characteristics of acids and bases. So let's look at some properties of acids and bases. As we have learned, Arrhenius says that an acid produces hydrogen ion in solution, H+, whereas a base produces hydroxide ion in solution. Bronsted-Lowry, on the other hand, says that an acid is a proton donor and a base is a proton acceptor. As far as taste is concerned, an acid would have a sour taste. Vinegar, if you were to taste vinegar, it has a sour taste, whereas base have bitter taste. Litmus paper. Acid turn litmus paper red, but bases would turn the litmus paper blue. If you were to touch acid, which you should not do, an acid will feel dry or wet normally, but some acids are very dangerous. They can burn you. Bases would feel slippery. Lastly, acids and bases react together in solution to create what we call neutralization reactions. This is a topic we'll talk about in some other presentation. All right, thank you. That is the end. Please remember to subscribe, like, and share, and let us know what you think about our presentation. Thank you.